The goal of this short video is to show a possible proof of the dot product. We'll call theta the angle between the two vectors, and then sketch the vector going from the head of V to the head of U. And this would be the vector U minus V. So first, using the law of cosines, we can try to find the magnitude of vector U minus vector V. So we would take the square of the magnitude of that vector and set that equal to the square of the magnitude of V plus the square of the magnitude of U minus 2 times the magnitude of V times the magnitude of U times cosine of theta. Another way that we could write the vector U minus V is with its components, and so we would just subtract the components in this order. And so that would be C minus A would be the horizontal component, and D minus B would be the vertical component. Well, what if I use this other formula for finding the length of this vector using the Pythagorean theorem? And so we would have the square of this, which would be like your c squared, is equal to the square of the horizontal component plus the square of the vertical component. And simplify. So when we square a binomial, I would get c squared minus 2ac plus a squared and plus d squared minus 2bd plus b squared. We're going to kind of regroup. Okay, so a squared plus b squared plus c squared plus d squared, and factor out from the other two terms a -2. Well, the magnitude of v squared is equal to a squared plus b squared. Since vector v had components a, b. And c squared plus d squared is equal to the magnitude of u squared, minus 2 times the quantity ac plus bd. Lastly, since the magnitude of u minus v squared is equal to both of these expressions, we're going to equate them and simplify. Notice that the magnitude of v squared will cancel, and same thing for the magnitude of u squared. And there is a factor of -2 on each side, and so that will even disappear. So we're left with the magnitude of v times the magnitude of u cosine theta is equal to AC plus BD. Okay, so since these two expressions are equal, that gives us two methods for finding or calculating what we call the dot product.